Hi, welcome back to ARISTOTHINK. We are seeing a problem about physics, specifically about friction. This is the second part of the video. If you have just arrived now, please find the first part of the video. It should be on the link above there or in the description below. Certainly it is. Now, we have just found that block 3 is going to take 0.21 seconds above block 1. Now let's solve what's going on block 1. So we have block 1 here, 1 kilogram. Block 3 is on top. The only force that is acting, it is the friction force. And this friction force comes from the friction between block 3 and block 1. The only force exists between blocks is this friction. And this friction is constant, is mu n. Mu is 0.6, n is the mass, times acceleration of gravity to 1.2. Now, notice something. This friction is constant, and this friction is now going to push just block 1? What do you think? Because you have to know what is ahead of this block. Imagine I'm here. I am pushing block 1 with that force of 1.2 newtons. I'm not pushing only 1 kilogram. I'm pushing 2 blocks. You see? Now it's going to be different when block 3 goes to block 2. Why? Because now this force is going to push only 1 block. But while block 3 is on top of block 1, you have to think. It's going to push 2 blocks. So when we do F equals ma, the force of 1.2 newtons is going to push a mass of 2 kilograms, 2 blocks, block 1 and block 2. So what's going to be the acceleration for block 1? So acceleration on block 1 is going to be 0.6 meter second squared. This is going to be this acceleration. Now we have to find what's going to be the time. Not the time, we know the time. The time that block 3 stays over block 1 is 0.21 seconds. But now, this is what we're doing. Look, we're doing this chart. This is speed, this is time. So what's going on here? Well, block 1 is speeding up at 0.21 seconds. Is going to have some speed, right? And the acceleration, which is, this is for block 1. Actually, block 1 and block 2, okay? And what is the inclination in here? Delta V, delta T. This inclination, it is exactly this 0.6 meters second squared. This is the inclination, which is the acceleration. This is for block 1 and also for block 2. Why? Because they are together. Actually, when this force of 1.2 newtons is pushing this block, both blocks moving together with the same force, same acceleration, it behaves like a big block of 2 kilograms. But now I want to know this. What's going to be this final speed while block 3 is sliding over block 1? So let's go to kinematics. So V equals V0 plus AT. V final is going to be, it starts from 0 because it starts at rest, plus acceleration times 0.21, which is the time while block 3 slides over. This is 0.13 meter per second. So this is 0.13. Okay, now let's think. What's going to happen? This is block 1, this is block 2. So far they are connected. While block 3 is in here, it is pushing both blocks together, just like a big block of 2 kilograms. But once block 3 passes to block 2, something is going to happen. Why? There is no more force acting on block 1. Why? The only force which was acting on block 1, the friction force, was the friction that was originated by the friction between 3 and 1. There is no more block 3, there is no more friction. So that is why block 1 after continues with a constant speed of 0.13. And block 2 is going to continue to accelerate. So after this moment, the blocks, they detach. And block 2 is going to move faster, and block 1 is going to continue on his own at his constant speed of 0.13 meters per second. Now that this is clear, let's see what's going on with block 2. So let's go for block 2. For block 2, what's going to happen? Now we have block 2. Block 3 is on top. So friction force for block 3 is always trying to stop block 3, but for block 2 is pushing block 2 forwards. So the only force acting on block 2, it is still the friction force. The same friction force in here is the friction force that block 3 causes. It is constant and never changes because this friction arises from block 3. So the same force, 1.2 newtons. So F equals ma. So what is the force? 1.2. What is the mass? No, the mass is just 1 kilogram. Of course. Why 1 kilogram? Well, this force has only to push block 2. Block 2 is only 1 kilogram. So this is acceleration for block 2. HU equals 1.2 meter square second squared. So now something to notice. Compare those two accelerations. This is twice as much. Why? Well, this force has to push a 2 kilogram block. This is the acceleration it gives to the system. Now, the same force, 1.2 newtons, this is 1.2. So now the same force has to push only 1 kilogram block. So since it has to push half the mass, it's going to give twice as much the acceleration. Now, remember that inclination is acceleration. Now, what do we expect for this, the line for the speed of block 2? The same? No, it's not the same inclination. Because if we had the same inclination, we should have the same acceleration. It doesn't. The acceleration is twice as much, so I'm going to have a steeper value. You see? So maybe not that much, but either way. So let's make a little bit. So maybe like this. But still a different, more steeper angle. And this is going to be for block number 2. So this is 1 and 2. 1 and 2. And this is going to be only for block 2. Okay. Now, we have acceleration for block 2. What is left? We have to find final speed. We know that block 2 starts with this speed. But what is going to be the final speed? Let's see. Well, for that, we need to know how long block 3 is going to stop here. We know. Why? Because we saw at first that block 3, is going to go up to 0.75 meters. So it's going to go all the way here and stop in the middle of block 2. So we have to find how long is block 3 going to stay moving over block 2. We need this time because we have to know for how long this acceleration is going to last. It's going to last as long as block 3 is moving over block 2. And what's going to be this time? So we are going for block 3 now. Block 3. Here, we need some space. So let's go for block 3. For block 3, what do we have? I have to find how long it's going to be. Well, I do know the final speed, don't I? The final speed for block 3 is going to be 0. It's going to stop. Well, let's use this basic equation. I think it's enough. So V equals V0 plus AT. So what is final speed for this? Is for block 3, okay? Let me just write, I'm sorry. You see, the solutions, they have to be organized. Some people just write numbers. No, there are words. So, how long block 3 moves? How long is going to be? V final is going to be 0, is going to stop. V initial 3 meters per second. Plus, what is acceleration of block 3? Always minus 6, always minus 6. Time. So we just pass 3 over here. So, okay, so time is going to be half a second. So block 3 is going to move 0.5 seconds. There is another number here. This is going to be like this. Agree? And when block 3 stops, block 2 continues with a constant speed. Of course, because after block 3 stops, friction disappears. If friction disappears, there is no driving force propelling block 2 forward. So time is 0.5. Yeah. So what is this delta t? Is going to be what? 39. Oops, 29. Sorry. 0.29 seconds. So block 3 is going to be 0.21 seconds over block 1, giving this acceleration to block 1. And once it passes to block 2, is going to stay. So block 3, over 2 is going to be exactly what? All the time block 3 moves minus what is how long it stays over block 1. So 0.29 seconds. And this time is the time this speed is going to be, this acceleration is going to be used to speed up from 0.13 up to, let's see. So what is going to be the final speed for block 2? So let's see in here. So for block 2 now, V final is going to be the initial 0.13 plus acceleration 1.2. The time, let's see my notes. What is this going to be? This final, second, it's a big problem. 0.48. So this speed is going to be 0.48 meters per second. So let's update this chart now. Here. Let's update this chart. Now we are close to the problem. And the speed for block 3 is very piece of cake. So this is going to be the final parts. Let's build finally what they are asking us. Time in seconds, always put the units, and this is the speed, which is going to be meters per second. Okay. Now we have to, for block 1. Block 1 moves up to 0.13 meters per second. This is the time while 0.21, the time while block 3 stays on top of block 1. After block 3 goes to block 2, block 1 continues steady with the same speed forever. This is block 1 and also block 2, both. Now, once block 3 goes over block 2, it's going to speed up block 2, so I don't have this line doesn't continue. I'm going to have a steeper line for block 2 only. Now this is 0.5, which is when block 3 finally stops on top of block 2. At this moment, block 2 is going to go from 0.13 to 0.48 meters per second. And now, what is the speed for block 3? Well, block 3 starts at 0, goes to 0 in half a second, isn't it? How long block 3 moves? So I could draw a different chart, but I'm going to use the same one. So I'm going to do this. You see, when you want to cut your chart for some reason, so I cannot put 3 in here as a continuous line, but if I dash it, it has a break in here. So what's going to be the speed for block 3 is going to start at 3 and it's going to 0. No, it's not. It's not going to 0. Haha, of course not. Why? Because block 3 is not going to have 0 speed. It's going to have the same speed as block 2. Why? Well, it's going to be on top of block 2 moving forever. You see? So it's going to go like this, and here it continues. So this is the speed for block 2 and also block 3, and this is the speed for block 3. You see? So block 1 is speed up, continues, steady. Block 2 is speed up. Now that block 3 is on top of block 2, it's going to be even with higher acceleration, speed faster. And once block 3 stops, it continues. Now block 3 is going to go from 3 up to the same speed as block 2 because they're going to move together. So this is the problem. I hope you have enjoyed. It's not an easy one. There are many parts, you see, everything is on the blackboard. So please, I hope you have enjoyed this video. It's not easy to make videos. I may have to make several versions of it. I hope you have enjoyed. It covers a lot about physics. It's a good exercise to see if you know about kinematic equations, if you know about forces, if you know about what happens when to add masses. For instance, why can't you put the mass in here if I just consider mass 1? And if I have block 3 on top of block 1, some people might wonder, why don't I have the mass as 1.2, for instance? Because they have different acceleration. Whenever you have blocks with different accelerations, don't add masses, please. Treat them independently. So things like this. So maybe you have to review this problem again. Try to do it yourself if you can't, but try. Do this exercise, do it yourself, and then if you have any issues, go back into this video. Thank you very much. If you didn't subscribe, please consider subscribing to the channel. It's going to help a lot. And if that was interesting, please give the like. It helps a lot the channel. It's very important for the channel when you give a like, of course, if you think the channel deserves. Thank you very much. See you next time. Bye bye.